excuse me, is looking at eclipses and tides. So eclipses we've kind of touched on when we looked at phases of the moon, but we're going to go into the details of how they happen, and we're also going to talk about the tides and where tides come from. So let's go ahead and get started. So we'll start with eclipses. All right, every once in a while we see that the moon, Earth, and sun line up just right, and we have something happens that's called an eclipse. All right, and there are two types of eclipses. There are what we call solar and lunar eclipses. All right, so you guys are going to take your own notes for the eclipses section, and then I'll jump in again with tides. So for eclipses, we have two types of eclipses, solar and lunar. And we're going to start with a solar eclipse. And a solar eclipse, a good analogy to this is something like if your little brother or sister or dog or mother or father or whoever is standing in front of the TV, all right? That person is blocking you from seeing the stuff on the TV, and the moon is basically become like that person, all right? They're standing directly in front of the TV, they move between the sun and the earth, and they've blocked sunlight from reaching the earth. All right, so when the moon is blocking this sunlight, we call it a solar eclipse, all right? And so you want to make sure you definitely define that over here. All right, again, you guys are taking your own notes on the eclipses section. All right, if the moon though is pretty small compared to the sun and the earth, so it only blocks all of the sun's light in some places. All right, you can see this really dark area right here. That is an area of complete shadow. No sunlight gets through. The moon is totally blocking all of the sun's light in that places, and we call that the umbra. All right, and that causes a total solar eclipse. All right, so if you were in the umbra, you were getting a total eclipse. You get no sunlight. Other places, though, in these lighter areas, only have partial shadow. You can see how the sunlight from over here isn't blocked by the moon at all before it hits Earth. Sunlight from over here is, but sunlight from over here is not. And those places only have some light blocked. We call that area of partial shadow the penumbra. Good way to remember that. Partial shadow, penumbra, partial eclipse, meaning the sun would be partially blocked. And this is what this total solar eclipse will look like from Earth. This big dark circle here is the moon, right? This is a new moon, obviously, since it's between the sun and the Earth, and the moon has moved in front of the sun. You guys can see these solar flares that show up. It's pretty sweet. We talk about the sun later this week. We'll talk about what all that cool stuff is. So that's a solar eclipse. Our next option is what we call a lunar eclipse. All right? And a lunar eclipse is basically the opposite. So here, the Earth is moving between the sun and the moon. Right? The sun is always kind of on its own. We just have the moon moving around the Earth. Right? So we're never going to have like moon, sun, Earth. That doesn't work. When the Earth's shadow falls on the moon, we get a lunar eclipse. So a total lunar eclipse would occur if the moon is in the Earth's umbra. Right? So in this diagram, they're showing a total lunar eclipse. Right? The Earth's totally blocking all sunlight from reaching the moon. A partial lunar eclipse would be if the moon is in the Earth's penumbra, which is what we had last weekend. The moon was in this area of partial shadow, so some light was getting through, but not all. Right? And a total lunar eclipse actually looks like this. Oh, it's very red, not dark and shadowy. We'll go over in class tomorrow why that is. All right, so just keep that in mind. All right, it's pretty sweet, but it definitely turned bright red, which is really cool to see. So that's eclipses. Next up, we've got tides. All right, so tides are pretty cool. If you've ever been to the ocean, you should at least know what a tide is. Right? Tides are the rise and fall of ocean waters over a period of about 12.5 hours. All right, so the tide will rise for about 6 hours, a little over, fall for about 6 hours, and then repeat. All right, so this shows the same area at high tide, down at the bottom, and low tide up at the top. And different areas will have different amounts of what we call tidal difference, and that is mostly determined by what the seafloor looks like. Some seafloors funnel tides, so it gets a really big difference. Some don't. What we're going to focus on here is why this happens. How does the moon cause this movement of water on the Earth's surface. So we're not going to worry as much about the tidal difference and how much the tide moves up and down as to why it moves up and down. And it turns out that has to do with gravity from the sun and the moon, but mostly the moon. The sun, we'll see, has a role in making tides bigger or smaller, but the moon is what really causes the tides. And so the moon, so tides we have causes. All right. You guys are hearing a little noise in the background. The fan on my computer just turned on, so it's probably pretty noisy. So anyway, we've got the moon's gravity pulls water towards it. All right, and we see that in this red arrow right here. So it's pulling some of the ocean water on this side of the world towards it. And that creates one high tide bulge on the Earth. But we actually have two high tide bulges at once, right? In order to get 2 high tides a day, we're going to need 2 high tide bulges. So where does this other one come from? The one on the back doesn't really seem to make any sense, right? The moon is over here, so the water should be getting pulled that way. That one makes a lot of sense. And this one, though, doesn't seem to make as much sense. What's happening is the moon is also pulling the Earth towards it, just a little bit. You can see with that red arrow right there. And that creates a second bulge on the back side of the Earth from water that gets left behind. So you can imagine there's water here, and all of a sudden the Earth gets whoop, pulled away. So there's a bulge of water left behind. All right. So we can say the Earth is also pulled to the moon. All right. Leaving a bulge of water on the back side. I misspelled bulge, no D in bulge. Alright, and so the reason why tides change living in place is the Earth is rotating through these tidal bulges, right? The water is always going to be pointing towards the moon and away from the moon, but the Earth is constantly spinning underneath us. Remember, everything's always moving. And as the Earth spins underneath, it moves through these tides. The Earth spins through tides. Lastly, how does the sun play a role? Right, the sun has creates what we call spring and neap tides. And what this is just some older terminology to describe really big high tides and really smaller high tides. So if the sun is lined up with the Earth and the moon, the high tide is higher, and we call that a spring tide. All right, which makes sense. The sun's gravity is adding into the moon's gravity, so that bulge is just a little bit bigger. The Earth is pulled a little bit farther, so that bulge is a little bit bigger as well. All right. If the sun is totally out of line with the moon, oops, that should be over here. Sun is totally out of line with Earth and the moon, then we get a lower high tide, or smaller high tide, we'll say, rather than lower. And we call that a neap tide. So something to think about before tomorrow is what phases of the moon would cause each type of tide. All right, there are 2 phases that would cause a spring tide and 2 phases that would cause a neap tide. So for tonight, see if you can figure that out. Which phases would cause the spring tide, which phases would cause the neap tide. All right. We are done with our notes. We're going to switch up the end a little bit. All right. Instead of doing a summary, I got this from Mrs. Sandler. What she's been doing is at the bottom, let's put 3 questions that you have after the video. All right. It can either be questions you have about the stuff in the video, or if you feel like you have a good understanding, try and think of 3 questions that extend this topic. So extensions of what we've talked about here. Alright, so 3 questions at the bottom, either about the material that we just covered or that take this a little bit farther. And I'll see you guys in class tomorrow.